Can your brain compile Java? This is a fun exercise. I give you some Java code and you have to predict if it compiles, what the output is, and if it doesn't compile, why. So just the slides, no IDE, no syntax highlighting, etc. And it's a lot of fun. So compiling Java. Maybe let's see how a Java compiler works so your brain can adapt. So the source code that you write is usually a couple of lines, right? A two-dimensional structure on the screen. But the compiler just sees a very long text, a sequence of characters, and then you have some line breaks here indicating where the next line starts. But the compiler just sees a long list of characters. And in the first phase, we call it the lexer, converts this sequence of characters into a sequence of lexemes or tokens. They're not the same, they're not synonyms, but the distinction is not important for this video. Okay, so we have some keywords here, identifiers, keyword, identifiers, semicolon, brace, equal sign, etc. So no problems here. And then the parser tries to convert the sequence of tokens into a syntax tree. And again, there's no problem because the compiler understands, we want to define a class. The class has two members, separated with a semicolon or terminated with a semicolon. Okay, all is syntactically valid. We understand we have a class named Foos, two members. Here's the first member, here's the second member, names, types, access, privilege, etc. So no problem here, parsing the token sequence. And then another phase, semantic analysis, comes and kicks in and then finds a problem, right? It determines, wait a minute, here we have a field named foo, and then we try to define another field named foo. That's not allowed in Java, right? It's a semantic error, and it's not a syntax error. That's the point I want to emphasize. It's not a syntax error to have two variables with the same name. It's a semantic error. And I want to emphasize this because I promise that none of my code examples have syntax errors in them. So you don't have to chase braces or see if I maybe exchanged a semicolon with a colon just for fun or something. I didn't do this. So everything I show you, if it doesn't compile, it's always a semantic error, like a type error, or maybe there's a method that has a return type, but I forget the return statement. Another example of a semantic error, right? No syntax errors, I promise. So let's look at the first example. Some Java boilerplate code. And then here's the interesting part. What does x minus z mean in Java? And here are some possible answers. Maybe if you see this x and you subtract something that isn't here, maybe it stays x, right? Okay, or maybe this is like a sequence going from x to z. That would be x, y, z. Or maybe the distance between x and z would be 2 steps from x to z. Or maybe the number of characters, x, y, z is 3 characters. Or maybe it doesn't compile. CTE stands for compile time error. Maybe it crashes at runtime. RTE stands for runtime error. Or maybe it's none of these choices, right? This is none of the above, although the options are to the left. Maybe I should have written none of the left, but that's not a very common abbreviation. None of the above means anything else, any other answer you may come up with. Okay, so now I have no way of knowing how long you need to think about this problem, so I suggest you now pause the video to think about the answer that you believe to be true, and then you unpause the video and then I will explain what's going on. Okay, so I hope you didn't cheat. I hope you really thought about it yourself. So, x minus z, what does this mean in Java? So in the Java type system, characters cannot be subtracted from one another, but there is an implicit conversion from char to int. So we simply take the Unicode values of x and z, which are shown here, and then we perform integer subtraction. And I hope you're convinced that if you subtract these two numbers, then you get -2, because the second number is bigger. Okay, so -2 is the correct answer. So lesson to learn is, if you have chars and you perform arithmetic, you always get an int back. Okay, so on to the next puzzle. Here I'm playing a bit with special Unicode characters. I think they're called combining characters. So this this special incantation \U0300 means I want to have a French accent, not in my voice, but as a character. And this is one of the 3 famous French accents. So it's either accent aigu, accent grave, or accent circonflexe. And I promise it's really one of those. It's not some weird other character or something. And well, which one does it choose? Or maybe it doesn't choose anyone at all. That's also a possible answer. So again, pause the video and think about the answer. Okay, so the solution depends on where you execute this code. This was really confusing to me. So in the Eclipse console, you get this accent, accent grave. And in the Linux terminal, I didn't see any accent. This was very surprising to me. I would have expected the same result. So I tried JShell. So if you write \U0300A in JShell, I think the problem becomes a little more apparent. So here you can hopefully see the accent is above the quote mark, not above the A. So these combining characters have to go after the character that you want to combine them with, not before. To me, this was somewhat counterintuitive. So if you say A and then the magic incantation, you get the correct result. And what's maybe a little surprising, if you put this into a string builder and then reverse it and then convert back to string, we have the error again, because reversing on a string builder reverses the char values, right? So the A goes here and this combining character goes here, and then we have the original problem again. So we have to be very careful. Some characters in Unicode are larger than 1 char. This has historical reasons. I think in 1995 Unicode only went up to 16 bits and then it had to be extended. What a mess. But I'm not a Unicode expert. Okay, beware of those Unicode issues. Maybe another video, but not by me. Okay, next puzzle. I'm comparing the string literal foobar to certain other expressions. So first I compared to well, the same string literal or another string literal with the same character sequence. Then I concatenate foo and bar with a plus sign and see if foo bar comes out. And then I concatenate foo and bar with a concat method, which does the same thing essentially as the plus. Okay, so again, pause the video and think about the answer. Okay, so I hope you understood that these 8 combinations are all that are possible, right? Each comparison could be true or false. Here are the 8 combinations. In case you weren't aware of that and were confused, pause the video again. So, right, so the result is true, true, false. So if you picked, where is true, true, false? Here. If you picked this one, you were correct. Because this operator compares string references, not string contents, but the Java language specification says that if you have 2 string literals with the same character sequence inside, then they are guaranteed to be represented by the same string object. So there's a string pool that is maintained at compile time, which guarantees this property, or maybe it has to have runtime support. Oh, you can look this up for yourself. I'm not sure. And the Java language specification also says if you concatenate string literals with plus, the compiler is smart enough to do this concatenation at compile time. And again, you get the same result, the same string object. But if you use the concat method or any other method, they will be executed at runtime. Right. I suggest that you don't learn these special rules, but instead you should always use the equals method, not this operator. Then you won't get any surprises. Okay, next puzzle. So here we have a class with a field, a setter for the field, and a method with a parameter, and all we do is write to the terminal the field concatenated with the parameter. Here we call the setter, here we call the write method. And, well, again, what does it print? Some possible solutions: cool, not cool, does not compile, crash at runtime, or none of the above. Pause the program and pause the video and think about the answer. Okay, so let's look at the answer. The answer is a compile time error. So we are inside the main method. Main is a static method, meaning we call it directly on the class prefix writer. We don't need any objects. But of course, these instance methods need an object to be called on, right? So we haven't created an object yet. So beginners often think, well, I'll just make this method static and this method also and this field as well. That's not the point of the exercise. Just create an object of prefix writer. Like this. Here I've created the object. Then I call the methods on this object, and the rest is basically the same. So again, pause the video and think about which of these solutions is the correct one. Okay, so let's look at the answer. The answer is null cool. This is very interesting. So here we declare a field. String is a reference type, so we initialize prefix with null, or Java does this. Null is the default value for string variables because string is a reference type. And this setter declares a local variable of the same type and with the same name. So this variable shadows this variable. So this assignment or this initialization, is it really, does not change the field. It only changes this local variable, which immediately goes out of scope. So most IDEs should warn you, hey, you declare a variable and you initialize it, but then you never do anything with it. That's probably not right. Okay, your IDE should probably give you a helpful warning here. So why doesn't it crash with a null pointer exception at this point? Well, there's a special rule in Java which says if you concatenate the null reference, it is first converted to a reference to the string null. Just some special Java rule. So if you ever had the string null on the console instead of a null pointer exception, it was probably due to this special rule. Okay, so on to the next code snippet. Here we have a loop which goes through some even numbers, incrementing by 2 each time. And the question is, how many dots does this program print? Right? I just run the main method once from top to bottom. So how many dots are printed? Here are some possible answers from 0 to 4, all the usual suspects you see here. So pause the video and try to think about the answer. Okay, so let's look at the answer. I hope you noticed the semicolon. This is not a syntax error, this is allowed in Java. You can write a semicolon directly after a loop header, and this means the loop body is empty. Right? So however many times the loop body is entered, nothing is done. Please repeat nothing n times. Okay, and after the loop is done executing, we execute this block of code once, because it has no association with the loop. It just is executed after the loop. Okay, so it's not a syntax error to put statements in a block just for fun. Right? You can put blocks where a statement is required in Java, no problem whatsoever. And at least my IDE does not warn about this. So this should be a red flag, and combined with this block should be a blood red flag, in my opinion. Okay, just in case you wondered, it doesn't really matter for this outcome, but how often is the empty loop body entered or executed? So we start with I equals 4, and then we compare, does 4 equal 8? No, it doesn't. So we immediately stop the loop. We don't even enter the loop body once, because the condition is a while condition, right? While this condition is true, execute the loop body. It is not an until condition. This is I see beginners making this mistake all the time. They write a condition they expect I to have at the end of the iteration. Okay, right, but doesn't change the outcome. It doesn't matter how often you execute nothing before you execute this block once. Okay, so next puzzle. Puzzle about floating point numbers, one of my favorite topics. So we have an accumulator of type float, then we have a loop. Inside the loop we increment the float with a prefix increment. And well, how often does this loop how often does this loop body, and here it's really the loop body, how often does it execute? So we start with 0, and we pick all numbers that are at least as big as 0, and we increment I. So basically, how many numbers are there starting from 0, going up to the biggest integer? Okay, and then what value does f have when the loop exits? Okay, so this is integer max value. So this means exponentiation on this slide. It doesn't mean bitwise exclusive all. Integer max value. This is integer max value plus 1. This means the loop never stops, infinite loop basically, and the usual suspects. So stop the video and think about the answer. Okay, so what's the answer? The answer is 777, what a mouthful, 216. In case you're unfamiliar with this notation, this means 10 to the power of 7, so basically 1.6 whatever times 10 to the power of 7, which is 16 million whatever. So why is this the case? Let me go into the J shell again. So 16,777,216 as a floating point number. F means float, float literal. And then I add 1. I hope you can see this. Maybe it's more obvious if I cast it to int. It's the same number again, right? So 16,777,217 is not a member of the float type. Okay, that's because due to the limited number of precision bits in float, maybe you can research this on your own. Very interesting topic. So basically, after the 16 millionth iteration, f will never change again. It will stay at this number. So if you subtract 1, this is no problem, right? 15, just like you expect. But this number with the 7 at the end is basically the first, it's the smallest positive integer that cannot be represented as a float. So you can add 2, no problem. So we are at a range of float where only even numbers can be represented. And if you add 3, again, it doesn't exist, 219. So you may expect this to be 218 again, but in fact it's 220. So sometimes we round down, sometimes we round up. There are good reasons for that, but those are not the point of this video. So maybe again, beware of floating point. And if you need a counter, why are you using float? If you want to count 0, 1, 2, 3, etc., just use an integer. That's what they're for, right? Or a long. Maybe a long would be better in this case due to overflow. Maybe you don't want to get a negative number here or something. You would probably get integer min value otherwise. Okay, so on to the last puzzle. Again, strings. We all love strings. So here we construct a Futurama character. I hope you're not old enough. I hope you are old enough to remember Futurama. And then we try to extract a substring of Bender. Okay, so what will this print? I hope you're familiar with the substring operations, what the parameter means. In case you're not entirely certain, I hope you find your suspected answer in this long list of possible answers. I hope I covered all the grounds. So think about it and pause the video. Okay, so what happens here? I hope you remember that strings are immutable in Java, right? So s.concat_dir will indeed have Bender as a result, but s will not be affected by this. Let me show you this in the J shell. So I have ben, okay, and then I call the concat operator. I cannot type today. I concat dir, and the result of this expression is Bender, right? Here it is, Bender in all his glory. But s is still bound to the string ben, right? We didn't change s. If you want to change s, you have to write s equals s.concat_dir, right? I want to refer to it to the result of this expression, and you can see it here, but if we want to check just to be sure, s is now bound to the string Bender. So unless you see an assignment somewhere, a string variable will never change, and the string objects can't change by definition. Strings are immutable in Java. So if this is somewhat confusing to you, let's pick a simpler example. Let's have an int, a variable initialized with 42. And what is a times 10? Okay. A times 10 is 420. I think this also has some significance. Can't remember right now what 420 means. Okay. So the result of a times 10 is 420, but a still has the value 42, right? If you want to change a to have a different value, you have to say a equals a times 42, and then 10. It should have been 10. I'm sorry. Let me do it again. 10. 42. A equals a times 10. Right. Then we have 420. I was a bit confused at this point, but then I saw my mistake. Right. Okay, so strings basically try to behave like numbers in Java, except that you can't compare them with this comparison operator, as we already saw. Okay. So, at this point in time, s still has the value ben. As you can see here, ben has valid indices 0, 1, and 2, and 3 is the first index after ben. This is very important. And 4 is an invalid index, right? I can't say I want a string starting here and ending here. This is an exclusive index. So I could say 1,3, then I would get en, and then it would stop here. This is a stopping point, basically, an exclusive index. And if I wanted to have the whole string, I would say 0,3. Then I would get ben. And this may be confusing to you. Why is this not the index of the last character? It's just convenient because if you subtract these numbers, you get the length of the resulting substring. And if you have multiple substrings in sequence, you can use the same number twice. Let me show you this. This is maybe a little confusing. So if you say hello world substring 0,5, you get hello. And if you say like this, I can now take the 5 and put it here. And then 5 is here, 5, 6, 7, 8, 9, 10. Right? So I can just, wherever I stopped, I can start off again, and I won't miss any characters, and I won't have any duplicate characters. So I like this convention. It's C++ has a similar convention in the STL. The end iterator always points after the end, not at the end. Okay, so here are the lessons that we learned. You can't perform arithmetic operations on types below int. If you have a char, it's converted to int first. Same for byte and short. I didn't show you this. Chars are not characters, but code units. Very interesting to dive into Unicode. I'm not an expert. You should use equals to compare strings, not this operator. Then local variables can shadow fields. In other programming languages, local variables can even shadow other local variables if you have nested scopes. That's not possible in Java. Then beginners have to be careful not to put semicolons after the loop headers. They'll get an empty loop body as a surprise. In case you ever need to know this is the smallest positive int that does not fit into a float. So if you need integer numbers, use int, not float. And remember that strings are immutable. You can't change the objects, the string objects, and if you want to refer to a different string object, you have to assign to the string variable, right? Otherwise, you'll have no effect. Okay, that's all I've got for you today. If you enjoyed this, I can record more videos of this kind. Goodbye.